All right, so up next we have, so welcome back, and up next we have Ryan Baker, and I am very excited to have Ryan with us. And Ryan is, among other things, director of the Penn Center for Learning Analytics at the University of Pennsylvania. His lab conducts research on engagement and robust learning within online and blended learning. His credentials don't really fit on one slide. He's the founding president of the International Educational Data Mining Society. He's the current editor of the journal Computer-Based Learning in Context. Many, many other things. He's co-authored published papers with over 300 colleagues. And so really, rather than I tell you about Ryan, what I want to let you do is listen to Ryan. So if you could please welcome Ryan Baker. And Ryan, come on up.
Thank you all for welcoming me here today. Thank you for coming. This is my first time speaking at a conference in person since 2019, so it's kind of a little bit wild. Great to be back, kind of able to do this. Thank you all for being here. So, in recent years, there's just been an explosion of data on learners and learning, and we're instrumenting more and more of learners' experiences from kindergarten all the way to corporate training and everything in between. And a lot of this data comes from places like learning management systems, adaptive learning systems, school information systems, but there's so many other sources of this data. It's just a great proliferation of what we can instrument so that we can learn more. And we're not just collecting this data. If we were just collecting and doing nothing with it, it wouldn't be very useful. We're actually, as a community of scientists and practitioners, using it, developing algorithms using what's sometimes called machine learning or educational data mining or learning analytics. Basically, you know, the art of taking the increasingly voluminous data on learners and learning and trying to make a value of it using kind of modern methods that can process it semi-automatically. And these algorithms can make predictions and inferences that we can then use to benefit students, support instructors, support other stakeholders in making decisions. There's a lot of applications of these technologies, including things like the prediction of dropout, success, and failure to try to figure out who's going off the rails and how to get them back on. The automated detection of learning, engagement, emotion, strategy, other things for better individualization. Better reporting for instructors, academic advisors, and other stakeholders. And basic scientific discovery and education. So both practical and more pure research benefits. But one of the problems in this kind of very utopian vision, this very exciting moment, is that we're increasingly seeing that the algorithms that underpin these technologies are often biased against historically underrepresented learners, functioning less accurately for these learners, and often making systematic errors not present for learners in historically overrepresented groups. So these algorithms both function less well in general for the people who might even need the most, need the benefit the most. They also kind of make systematic errors in those cases. And as probably everybody here knows, this is far from unique to education. This is a broader problem in algorithms. Algorithms have become this kind of universal thing impacting everybody's lives, but the quality of them sometimes isn't quite as high as we think it is, particularly for those who society has historically less supported. This example from Garcia 2016 is kind of at the edges of it. It's in an educational domain, and it has to do with a hospital medical school in the UK using a computer program to do screening of applicants. And this program tried to mimic the decisions made by past admissions staff and said, okay, well, they didn't admit women, so we won't admit women either. And this is the kind of horrifying thing that can happen if you do these algorithms wrong. And I'm going to give some examples in a minute that are going to show this kind of stuff didn't stop in the 1970s and 1980s, unfortunately. Another example from Garcia from a little over a decade ago involved where a credit card company directed applicants to apply for cards with higher interest rates if they were from minority groups. So, and I could just go on and on with examples. The ProPublica's example where they found that defendants who were black were rated to be more likely than whites to be at high risk of committing a crime if they were released. So they kind of made estimates that might have been based on past data, and part of the problem is that the past data itself was likely contaminated in various fashions. For example, if judges are more likely to apply a stricter sentencing criterion to people of some races than others, and the algorithm is trained to replicate what those judges do, then the algorithm is going to replicate that bias. So algorithmic bias, I'll talk more about this in a few minutes, can come both from replicating the biases already in society, but equally as problematically, it can come about by creating new biases simply when groups are less well represented in the data. So there's a lot of reasons why these things come up. Classic definition of algorithmic bias, Friedman and Nussbaum: biased computer systems systematically and unfairly discriminate against individuals or groups of individuals in favor of others. And the working definition that Aaron Hahn and I came up with and I showed his picture up at the beginning. Aaron and I wrote a review on algorithmic bias in education that I'll talk about in a few minutes. Our working definition was cases where model performance is substantially better or worse across mutually exclusive groups separated by non-malleable factors. So sometimes models will work less well for groups of learners where the learners can actually go between groups. For example, if a model is less effective, say, for somebody who hasn't had a certain educational experience, but they can relatively easily get that educational experience, it's not necessarily as problematic as if a model is less effective for somebody who cannot change the variable that the model is less effective for. Any questions on this definition before I go on? Yeah. Hopefully fairly intuitive, but kind of a cornerstone to what I'll be talking about. So where does algorithmic bias come from? And maybe part of the answer to that comes from where do algorithms come from in general? A few folks, and kind of most recently put together in a review by Kizelchek and Lee, talks about the machine learning life cycle, which says that, for example, actually see if I can, laser pointer, wow. Ooh. Laser pointer. 3 years, right? So we have a state of affairs in the actual world, right? Oh, that's actually.
Yeah, but you can get your mic off.
Wow. How about that? Boy, it's amateur hour up here today. So we have a state of affairs in the actual world from which we figure out what we want to model or predict. That's the task. We collect certain measurements or data from the world to be able to detect that. We then conduct learning of a model, and that model tries to be able to use that data in order to predict the thing we want to predict. We then take that model and we deploy it in the actual world, right? So we actually put that model in the world, which changes the world. That's part of what's interesting and tricky about modern uses of machine learning and artificial intelligence, is that if we're doing things right, we're actually changing them. And you can imagine that it's actually an interesting problem. For example, I've been involved in building a predictive analytics system for high school dropout. That what's interesting is that because we make these predictions, we give these. And this is a widely used system. It's used at scale. I think it's currently the second or third biggest in the US, about 1 million kids a year. And because it can give good information to teachers and school leaders about who's at risk and why, the teachers and school leaders intervene, which means that our model looks like it's getting worse every year because we're breaking the relationships that it was catching in the first place. In other words, if a student, say, has a lot of absences of the first 30 days, we detect that. The school leader makes an intervention, talks to the kid. Well, if it works and the kid becomes less likely to drop out, then the predictive power of absences of the first 30 days goes down. So that's why we have this ongoing cycle where we're constantly having to redo our models based on the world that we've created through our models. So there's been particularly high interest in this phase, the model learning phase of machine learning, data mining, and how it can produce algorithmic bias, with people putting a lot of energy into questions like, okay, how do we make our algorithms better? And what algorithms are more prone to these kind of issues than others? And I'm not going to talk about that today because, quick raise of hands. Who here is a data scientist or machine learner who builds algorithms for a living? Right, that's why I'm not going to do it. I could spend an hour talking about value-sensitive classification and cost-sensitive classification and the relative ways that you can reweight models, and whoosh, it's very technical. So I won't be talking about that. I'll be talking about another part that Aaron Hahn and I have focused on, which I think is just as essential, I think actually more essential, for preventing algorithmic bias, but it's something that people who are building learning systems and collecting data from learning systems and working with people like me to build algorithms. It's something that y'all can be more involved in, those of you who are building these systems or overseeing teams that build them. And that's, what data do we collect? You can build the best, you can have the best algorithmic tools in the world, and my gosh, anybody who's read the news lately about like these things that can auto-generate pictures to prompts, or anyone who's ever played AI Dungeon will say, oh wow, this technology is powerful, but if you don't put the right data into it, you're still not going to get anywhere. And in particular, and I'll talk about this, if you don't collect the data that can enable you to see if there's algorithmic bias happening, you'll never see if there's algorithmic bias happening. And that doesn't mean you won't have algorithmic bias, it just means you won't see it. And if you can't see it, you can't fix it. So there's several sources, and I kind of foreshadowed this a little before. There's several sources of bias in measurement data collection. One of them is representational bias. And that's where the model performs less well for the groups that aren't as well represented in data used to develop models. And think here about those of you who oversee systems that are used for learners. The people who use their system, is that population of people fully representative of the people who may someday use it? And the answer is often no, because our workers in various settings often change. This happens a lot actually in educational technology for K-12, because it's really easy to collect data from some populations and not from others. Anybody here ever had the experience of working with the New York City Department of Education Institutional Review Board? A couple people smiling, most people shaking their heads no. So if I want to, and my center does both K-12 research and adult and lifelong learning. We're probably a little more lifelong learning than K-12, but we do a lot of both. And when we want to do a study in the Philadelphia suburbs, we go out to the school and say, hey, can we do a study? And they say, sure, and we're done. We have to go through institutional review board at our own university, but it's very, very easy. And if we want to do that in rural Pennsylvania, then we go out there and they say, sure, and okay, we have to drive out there. It's a little more of a pain. The last time we did a study in New York City, and New York City is not particularly different than any other city in terms of this. It was a several-month process of different approvals from different city organizations, being told that, for example, we couldn't even talk to teachers until we'd gotten full review, but then we had to have letters from teachers in order to get the full review. That was complicated to get around. So a lot of people don't do the research in the full setting. So if you build a model on data from suburban learners and then you take it to Jackson Heights or East New York, it's not going to work. And even a quote-unquote complete data set might not be enough if a group is rarely seen in the data. So an example of that would be Henry Anderson at the University of Texas at Arlington wanted to validate if his models that he was using for predictive analytics work for all the students at the University of Texas at Arlington. But it turned out that they only had a handful, I think it was less than just over 20, I think, Native American learners in the entire population they were looking at, which meant that he was unable to validate that the model would work for students in that group. And that's the problem that folks who do corporate training, lifelong learning are going to have. Not that you systematically don't look at those students like what happens in K-12, but that you just don't have enough members of certain groups to validate the algorithm. Another example of how these biases can creep up is, so a lot of times we build these models to predict something. And sometimes it's an outcome that's relatively straightforward, like high school dropout. Sometimes it's an outcome that is itself prone to bias, like say evaluations, where the people doing evaluations may be biased. Sometimes even people's judgments about themselves can be biased because things like stereotype threat, where people in certain groups become affected by the stereotypes about their own group and tend to judge themselves more harshly. That can influence their self-ratings. So attention has to be paid to the thing that you want to predict. If you build a model to predict it, is there bias in the very labels you want to predict? And there are very blatant examples in other domains, like judges sentencing people of some races more harshly than others. But when you realize it even affects people's judgments on themselves, it becomes a really interesting challenge and one that requires kind of constant vigilance. So, if we want to build models that are not prone to bias in order to embed them in our learning technologies, Han and I talk about a 4-step process where you start first with unknown bias. That's where the system is biased and you don't know how and you don't know in what ways. The first step to take from there is to known bias. If you can know how your systems are biased, then you can fix it. And from there, we can talk about going to fairness and to equity. So in other words, you can't fix the problems either at least making things not explicitly unfair and then hopefully trying to address existing inequities in your system. You can't do that until you know what they are. So what do we know about the bias impacting learners? And let's start with common demographic categories. And I'll move from common demographic categories to kind of less well-known categories in a minute. So Ken Holstein at Carnegie Mellon, in his interviews of industrial teams of adaptive learning system and educational technology developers, noted that the teams really didn't know what subpopulations to look at and what forms of unfairness they needed to look at for their specific kind of machine learning application. And Luc Paquette and his colleagues, in a recent review in the Journal of Educational Data Mining, although this area is moving so fast that 2020 doesn't actually feel recent to me anymore, but it feels like an eternity ago. Most educational data mining research doesn't even mention learner demographics, much less take a look at it and see if it's an issue. So I'm going to give a brief summary on the evidence so far. For full details, as of a year ago, see Baker and Hahn in Press on my webpage. In Press, I note, because that's how the journal publication process goes, right? We submitted in the February of 2021. We actually went through a very fast review process where it got accepted in the autumn, and we updated as much as we could at that point, and then it froze while it waits to be published. But it's up on the web. And then for the very most up-to-date info we've got, we have a wiki that we've invited the research community to update as they have new results. So, race and ethnicity is, of course, the category that most of the discussion out there of algorithmic bias pertains to, and for good reason. There's a lot of evidence that a lot of algorithms are racially and ethnically biased. In particular, in education, there's been several papers that show that education prediction algorithms perform worse for African American students and Latino students, including things like prediction of grades, course failure, graduation, and dropout. However, interestingly enough, automated essay scoring, a lot of people have expressed the hypothesis that that would be biased. But so far, there hasn't been good evidence that automated essay scoring is biased. And I think that's largely because the people who do automated essay scoring are psychometricians who have known about testing bias issues. Psychometricians were thinking about, if you look at like Google Scholar for the term algorithmic bias, you might be convinced to think that people have only been worrying about these issues for 4 years. But psychometricians in the testing industry have been worrying about these issues for about 5 or 6 decades. And so the people who built automated essay scoring typically were in that world and paid more attention to it. Self-regulated learning detection has been found to be largely unbiased, although, to be fair, the only study that looked at that was a study from my group where we were explicitly trying to make sure our algorithms weren't biased. So, not sure we can say about all self-regulated learning detection. Now, interestingly, when it comes to race, some folks have recommended predicting explicitly based on race. In other words, literally putting into your model predicting if a student's at risk what the student's race is. That is not a practice that I'm wildly in favor of. In fact, I've argued against it repeatedly, and actually a couple colleagues and I are writing a position paper on this right now. Because it can not only does it not often work at its goal task, a lot of the time it actually makes models less accurate, as Renjie Yu, who's actually joining Teachers College Columbia University this fall. So anybody interested in talking to an expert on learning analytics and student prediction and want to find somebody in New York City because you don't want to go all the way to Philadelphia for it, he's great. And it can also replicate the bias in decisions made by instructors. And I'll talk about the Wolf et al. Example in just a few minutes. As I mentioned before with Henry Anderson's work, there's been almost never enough data to test for biases impacting Native American learners, which shows how much, the biases impacting who gets access to even be in the data set are going to impact the quality of the algorithms for the people who do get into the data set. One exception to this is Christie's work, where they actually had all the high school data set from, I believe it was North Dakota, and so they were able to get a representative sample of Native American learners, but that's incredibly rare. Nationality. There's been evidence of algorithmic bias in terms of nationality. For example, on one test of foreign language proficiency, one system inaccurately gave students who spoke Arabic and Hindi as their native languages lower scores than human essay raters. In another study, models trying to look at student help seeking, when students asked for help from an online learning system to try to understand what strategies were best for which students, found that different strategies were effective for students in different countries. And in particular, if you built a model, which people tend to do, say solely on US data, it would work less well for learners from the Philippines and Costa Rica. Finally, in terms of nationality, models predicting standardized examination scores trained on data from the US, again, a common practice, were accurate for students in economically developed countries, but less accurate for students in less economically developed countries. One of my graduate students has actually been looking at this issue and has kind of seen that, like, for some models, the practice of training them on European and North American populations often leads to models that work well on European and North American populations. Gender. So gender is one of those things where in education there doesn't seem to be quite as much algorithmic bias in terms of gender as there have been in other domains. And I tend to think that's because the populations using educational technologies typically tend to be relatively balanced male-female. And so that hasn't been as much an issue. Sometimes models seem to be biased against female students, but sometimes models seem to be biased against male students. So there's not quite as much of a clear pattern here. Now, that's what we know about algorithmic bias in education in terms of race, ethnicity, nationality, and gender. And one thing you might be noticing is I don't have that many citations on these slides, right? And some of these names seem to keep showing up again and again, like Renja Yu here, or Lee and Kizelchek, or, hey, I mentioned Henry Anderson, right? There's Henry Anderson. And in fact, it's even a little worse than that, because that Lee et al. Paper is Kizelchek again, and that Ogun paper is got me on it. And gosh, it's a lot of the same names, right? Distressingly, despite how much we kind of now know about how big a problem this is, there's really still only a small handful of educational technology researchers paying attention to these issues. So what do we know about bias impacting other groups? Well, there hasn't been enough research even in terms of the very well-known variables that tend to be commonly collected. And boy, there's been even less in terms of other groups, even though it looks like there is algorithmic bias impacting other groups. And one question that's worth asking is, do we even know all the groups that are being impacted by this? So for example, native language and dialect. Algorithmic essay scoring is typically developed on corpuses that are more relevant to native language speakers than second language speakers. And this is one of those things that's been true of the design of tests for a long time. Automatic form post-classification, typically more accurate for native speakers than non-native speakers. One of the problems for algorithms for non-native speakers is they tend to have errors in the formal characteristics of their speech. And they tend to have nationally kind of, I should say, based on linguistic background, not nationally, based on linguistic background, characteristic errors that the algorithms typically can't handle. In terms of learner dialect, there's been no work on algorithmic bias in education. The closest we get is that there's been some work to develop learning systems that are appropriate for speakers of non-traditional dialects. Specifically, Finkelstein and Cassell's work on creating learning systems that are designed in African American vernacular English. But despite the fact that people around the world speak in non-traditional, I shouldn't say non-traditional, I should say non-prestige dialects, most learning technologies are designed for standard North American, or if they're British, receive pronunciation. They're not designed for Cockney or Glaswegian or the dialect spoken in West Virginia or Deep East Texas. I grew up near Deep East Texas. I understand it, but I don't speak it. So this probably matters. It certainly matters in other areas of algorithmic bias. Nobody's looked at it yet. Disabilities. There's been very little work on disabilities. Lucchina et al. Found that speech recognition systems used in educational assessments are much less accurate for students with a speech impairment. This is perhaps non-shocking, but it hasn't really been researched in detail. And Riazi and colleagues found that there was disparate impacts in course outcome prediction if students self-reported that they had a disability, just any disability. They didn't actually ask which one. That's the 2 studies on disability and algorithmic bias in education. So we need to do more. It's embarrassing to come to an audience of people outside your field and talk about how lousy your field is. But but part of why I do that, incidentally, is that so when you are all talking to vendors who are providing algorithms or talking to team members, ask them these questions. Ask, are you going to pay attention to these issues? You know, put a feet to their fire, put a fire to their feet. Urbanicity. Detectors inferring students' emotion, which an increasing number of learning systems are now looking at emotion and engagement, are significantly less accurate when they're transferred between urban, rural, and suburban students. However, this doesn't work as much. This doesn't apply to all problems. Parental education background, mixed results in terms of algorithmic bias in that, and the 2 studies looked at. Parental worker mobility, children who have a parent in the military, models trying to predict what their graduation and SAT score are going to be are a little less accurate. Few studies on socioeconomic status. Overall, there's strong evidence that bias impacts a wide range of groups. And given that some of these constructs, like say parental mobility for K-12 dropout, only involved a single study, it's pretty likely that we don't even know all the groups that are impacted. So one of the things to be asking is, again, when you have a vendor, who is providing you an algorithmic or predictive technology, think about who the groups are in your population of learners. What are some of the demographic variables and individual differences they have that you maybe should be looking to make sure it's valid for? It may vary from context to context. So overall takeaways here. Models trained on one group of learners tend to perform more poorly on new groups of learners. So if you change the population that you're training for, redevelop your algorithms, retest them. We need investigation of bias for many groups. When I gave this talk in Germany, somebody said, not exactly this talk, but a talk like this, a little more technical. Somebody said, what about religious minorities? And I've never seen a single study looking at religious minorities and whether there's algorithmic bias that impacts them. Collecting data from and training on a diverse sample of students can help. Maybe one lesson here is that if you're going to build an algorithm on a subset of your learners, don't pick the 12 that were easiest to get to. Actually be thoughtful about it. So this kind of work can take us from unknown bias to known bias. But the question is, how can we go forward from there to fairness and equity? So some key obstacles to overcoming bias. One of them is lack of data on group membership. How do we get here? How is it that people are collecting data on learners, but they don't know who their learners are? And one answer is that people don't think it's important. People don't think it's necessary to collect the data. Another one is privacy concerns. People definitely want to protect privacy. And one of the things that you have to do is find a way to protect individuals' privacy while not putting yourself to a point where you can't check for algorithmic bias. Especially in K-12, less so in higher ed and the corporate training world, there's been a big push towards privacy that has often caused people to make recommendations like never collect demographic information at all, which there's a certain sense to which demographic information can be identifying, right? If there's one Native American learner in a population, you have that variable, you've got at them. But for example, for gender, when you've got a group of students who's about half-half, there's really not much privacy question around gender assigned at birth. Also, there's regulatory and legal restrictions, which vary a lot by country. Your ability to do this in the United States is much higher than your ability to do this in Europe, most of Europe. And your ability to do it in the United States is also lower than your ability to do it in much of East Asia. China being, for a long time, the very notable case in that, but China's actually switched their legislation a little bit more towards the US lately. Another key obstacle to overcoming bias is the lack of transparency on bias and group-specific outcomes. And that's often because for a lot of vendors creating algorithms and predictive technologies, there's strong commercial incentives against being transparent, right? If you publish evidence that your corporate training solution is less effective for students from specific groups and all your competitors don't publish that, guess who's going to look bad, right? The people who are trying to do the right thing. There's also often monolithic presentation of evidence. And what I mean by that is, when people publish a study saying, my learning technology is good and it works, typically they just say it's good and it works. They don't say, it's really good for this group, it's pretty good for this group, but it's not quite as good for this group. Those of you who are pushing for, who are going to be judging evidence on technologies, or possibly in your communities pushing for standards on how evidence is considered, I would urge you to push vendors to report how their technologies work for members of different groups, not just overall. Because a result of, this is pretty good, can hide the fact that it's actually great for some people and mediocre for others. What are some other things we can do? We can improve data collection. We can collect data when possible on as many of these variables as we can get. And if I had my druthers, and this is what happens when you've got an academic, the academic says collect everything, right? That may not be feasible. You collect what you can. You don't collect things that might specifically identify one person. It's not going to help you anyways. You can't test for algorithmic bias with 3 people. Another thing that we're working towards, and we have a project with the University of Illinois, is in not just understanding learners in terms of the categories we impose on them as outsiders, but understanding learners in terms of the categories they use to describe themselves. A lot of people don't entirely feel comfortable with the labels that they're assigned by broader society, and they have their own ways of thinking of themselves. And sometimes there are large groups of people who don't like those titles. Checking for algorithmic bias in terms of the categories people think of themselves in, and looking at whether technologies are working for learners in groups where the learners may identify a group for themselves that we don't externally identify can be very valuable. There's also ways to reduce privacy risks. If you're in an organization that has a lot of concern about privacy risks, there are ways to reduce privacy risks without throwing out the ability to look for algorithmic bias. Things like data obfuscation. Data obfuscation is where, let's say you have only one member of a group, you merge it with another group, and so people don't know which people are members of the smallest group. Another thing, so at the University of Pennsylvania, we have a research data infrastructure where you can do analyses on unrestricted complete data, but you can't view it or download it directly. So that means that we can have these variables in there that people might feel concerned about being leaked, and we have them safely in our data infrastructure so that people can't actually see those variables. They can work with them, they just can't see them. So they can know, for example, that 42% of the students are a member of this group, the algorithm doesn't work as well for them, but they don't know that Ryan is a member of that group. We can also work towards making sure our training sets are representative. In other words, when you pilot a learning technology in your organization, make sure that the population you pilot it with is representative of the people who will eventually use it. Make sure you're not underrepresenting key groups just for convenience. And avoid bias during the labeling process. So sometimes people, when they're trying to code for things, to build models of things, of constructs that require human judgment, like say engagement or emotion, sometimes they'll have external people code it. Oker and her colleagues showed that if you do that cross-culturally, sometimes it doesn't work as well. So there's often the assumption that somebody in Silicon Valley can build something for everybody. And that's not always the case. So Oker showed that if you tried to categorize emotion and engagement in Turkish students, Turkish coders did better than American coders. Perhaps not shocking, but important to know. And relying upon human decisions like course grades or school suspensions or job performance reviews can capture the decision maker's biases. I have a couple examples on this, and the first one's from K-12. Todd Feathers, in a journalistic report, reported on a large national K-12 predictive analytics vendor that provides a model to schools predicting who's going to drop out of school that relies almost entirely on race and socioeconomic status to predict who's going to drop out of school. The model pretty much boils down to, like, way more than half of its predictive variance is, and I feel uncomfortable in saying it, but if you are black and you are poor, you're going to drop out of high school is their model. And if you're not, you're fine. That disserves everybody in a horrible fashion. And I was quoted in that article basically saying that vendors should be ashamed of themselves. And so was Alex Bowers at Teachers College, Columbia University. And it's a very large vendor. It's like if your kids go to school in a public school in this country, you've heard the name of them. So in higher education, Wolf included race as a predictor in a model predicting course grade. And they found that including race led to better prediction of course grade than a model that only used student assignment and exam grades. And you should be saying possibly, wait a minute, you're predicting the course grade based on the student assignment and exam grades. Shouldn't that model be perfect anyways? How could race make you better at predicting what a student's grade is in the course if you already know their assignment on all the exams and tests, and the grades on all the assignments, exams, tests? What could cause that? So, if you've got two students and they have the same grades on all the assignments, the same grades on all the tests, and one of them gets a better grade than the other one, and the one who gets the worst grade is a member of a historically underrepresented group in that country where the study was done, you've got a problem that predictive analytics cannot solve. Right? You've got a problem in your university. Unfortunately, this university decided to actually put race in their predictive model rather than solving the problem. Although earlier this year, they actually quietly abandoned that practice. I still have not heard of them, though, actually taking action on the clear racial bias in their grading. Facilitate and incentivize openness. These recommendations may not be relevant to everybody in this room, but to the extent that you can get your vendors or your standards organizations to push for openness on these things, the better it'll be for making sure that all the vendors are paying attention to this. Ultimately, we need to improve our tools and resources for doing this work to make it easy for labs beyond, high-end research labs to do this. We need to broaden the community, bringing in a broader number of people who are members of the community being affected by algorithmic bias. This is something that artificial intelligence needs in general to do a little better at. We're doing our best at the Penn Center for Learning Analytics to bring in a more inclusive community of scholars and encourage everybody to do that. Ultimately, by taking these steps to move from where most educational technology is, an unknown bias, to known bias, figuring out where our technologies are broken, and then use that knowledge to fix them, trying to move towards fair technologies or even equitable technologies. By doing that, hopefully we can build a world where learning analytics is benefiting everybody using our educational technologies, where it's not working kind of quietly better for people who are already advantaged than people who aren't. So I'd like to thank you all for your attention during this talk. Appreciate you all coming and hope you found it interesting. If you're interested in learning more, briefly, so all the publications I mentioned today are available online. Google Ryan Baker. I'm not the NBC Chicago news anchor, nor am I the Miami Dolphins linebacker. I'm the other one. We have a massive online open course, Big Data in Education, which teaches you a little bit about some of this stuff if anybody's interested in it. I also have all the materials for my course, Big Data Education and Society, which provides more readings on this. We have a Twitter and a Facebook feed where we put all of our latest scientific results. And in general, I would love to answer some questions now, but if anybody wants to talk to me later about these issues, feel free just to shoot me an email. I'm more than happy to engage, and I thank you all for coming. Please.
So thank you for your presentation, which was really inspiring, and it is really relevant and important. I wanted just to understand better. So you implied in a way that according to the bias that you detected through with these using these tools, that minorities or not underrepresented groups apparently perform better than what the system is expected them to perform. Am I right?
It can go in either way. Technologies can be inaccurate in either direction. I mean, particularly in some of those automated essay scoring examples, for a lot of groups, the technologies were systematically saying people were worse than they were. I'm sorry, not automated essay scoring. Speech recognition for English fluency. My apologies. But in other cases, technologies can be wrong in the other direction, and that can be just as problematic because then a technology might miss a student who needs support.
Yeah, but this, in my view, as a teacher, let's say so, means that there are some dimensions that are not taken into consideration, and in my view, you should have a wider picture to go to certain conclusions. And of course, underrepresented groups, especially as far as the language is concerned, and the language is the basis is essential to reflect, to think, to learn. Of course, they have less, forgive about my English, but
No worries.
they have less opportunities than, of course, a person raised in a white upper class environment. So the bias, if there's a bias, conclusions can't be, can be generalized if we don't have a bigger picture, in my view. But that's
Well, exactly. If we're not just to determine that our technologies are biased, but actually go to the point of making our technologies fair and equitable, we have to understand what the roots of the bias are. And those roots will be different in different contexts. For linguistic applications, it'll often have to do with the different linguistic characteristics of non-native speakers. In other cases, it has to do with the bias of the people's decisions that we're trying to replicate. So there's kind of no one cause to these problems, so much as there's a constellation of issues that we need to figure out before we just go ahead and use these technologies. I'm not saying we shouldn't use the technologies, because existing decision-making was also biased, right? Like for example, if you have an at-risk prediction algorithm, it's replacing the intuition of teachers and school leaders, which may actually even be worse than the algorithms in many cases. Or possibly human graders, and human graders might have been biased. So we need to kind of understand in each case what the problem is, so we can make these technologies able to resolve the issues that have probably preceded the algorithms.
yeah. Thank you.
Thank you.
Yeah, I wonder if you could speak to this. This is more from a corporate perspective. I managed knowledge management in 160, 170 countries, a lot of languages and so forth. And of course, when you're developing the learning technologies and the knowledge spaces, you need to be concerned about cost and so forth, and how many languages do you translate your e-learning into and that sort of thing. And one thing that came up where there was bias, and it took a long time to figure this out, was Brazilian Portuguese versus Portugal Portuguese. There are differences and so forth, but one thing that was hard to uncover and created bias was that there were about 7 terms that were peculiar to the travel industry, which this was, that meant the opposite things in the 2 different versions of the language, and that's not really, it's not. Does that mean one is not a native speaker? But
Dialect absolutely matters too, right? And dialect is really hard. I mean, I was talking to some folks who said they were going to make a language recognition thing that would work for the whole world in English. And I said, really? How are you doing that? And they said, well, we're going to every country, like literally 160, 170 countries, they said. And we're going to get speech from those people there, and we're going to do that. I said, oh, that's great. And within countries, you know, are you getting like the different dialects of North America or Britain? They said, oh, no, we're not doing that. That's too much work, right? So, I mean, we all make our choices. And being a fluent speaker of Brazilian Portuguese myself, and being shocked at how poorly I did at communicating in Cascais or Porto, it is really noteworthy, right? These things, there's a lot of subtleties, and it's a problem with all these labels. It's not just Portuguese, it's also when it comes to race. Like racial categories, who gets included and excluded in racial categories is really complicated. You know, my children are half Brazilian and a fourth native South American, and they are classified in certain ways in different U.S. states, right, as to what group they're part of because of that. So that's why we have to have more nuance, not less. But of course, when we do that, cost becomes an issue. And so we have to figure out for our own specific case, which are the variables that are most likely to be important.
What we found was in using the automated translation vendors, the best ones actually use a combination of real people who live in those areas,
Yeah.
right? And things are routed, you know, through all different translation engines and so forth to get rid of the bias. We actually switched vendors and solved part of the problem that way.
Thank you.
We actually have an online question, so I can pass this on from Medico Visto, and it's Kahneman points out also the concept of noise in human decision-making, and he asks, can we use machine learning to help us with that?
So by noise in human decision-making, I'm assuming, and correct me if I got it wrong, that you are referring to the fact that human decision-makers will make different choices about the same case. And that's in fact an inherency of these things. If you do machine learning right, what you can get to is an average of what the best coders, what the best human decision makers do. There will still probably be human decision makers who are more precise at whatever construct it is, but you can kind of control out for some of the noise. I think the key is to capture that signal, and machine learning up until very recently was focused entirely on catching the signal and discarding the noise. And what we're learning today with algorithmic bias is that some of that signal is actually also stuff we want to get rid of. We want to get rid of the signal that's the true signal and not the biased signal that comes with it because human decision makers are themselves flawed. That dream of objective decision making and objective prediction is, well, it is just that. It's a dream in some ways because it's impossible to make things perfect, but hopefully we can do better than existing systems. In the back.
Hi, so I teach undergraduates, and we have a unit on algorithms, and I've been using an older article to introduce just the idea. So I'm just wondering if you can give suggestions for introducing readings or strategies for introducing this material for people who are just generally unfamiliar with algorithms.
Algorithms or algorithmic bias?
Well, starting with algorithm, but getting to the bias.
So, for algorithmic bias, one of the challenges you find is that most of the articles on it are written by computer scientists for computer scientists. And that's not hugely helpful. I'd like to think that my article with Han was relatively better. It was designed for people to be read by people in education more broadly. Still not maybe for undergraduates, I don't know. You know, for algorithmic bias, I know you said algorithms first, but I'm going to go to there in a second. For algorithmic bias, I think that some of the newspaper articles and online journalistic articles, like the ProPublica article, I think that stuff's relatively good. I think Garcia's paper, and I quoted a couple times, is relatively good. If you email me, I'll send you the syllabus of what I use to teach on algorithmic bias to master's students in education, who are largely not specialized technically. As far as algorithms go, what we really need is a resource out there. We have a lot of resources that are teaching algorithms to people who've never done algorithms before but want to do algorithms. And Ian Witten's book, Frank and Witten, is actually a really good introduction for that. But that's not quite the same as a thing on algorithms for somebody who's not familiar with algorithms at all and doesn't want to do algorithms.
Yeah, those are my students.
Yeah, I don't have such a reading off the top of my head. The Massive Online Open course I have is still of that nature of people who don't know about algorithms and want to do them, which is not quite the same, and it's longer and more in depth. Nothing off the top of my head. I'm sure there's stuff out there, but it's not something I've specifically come across.
I've been using this MIT book that's old, though, so I'm trying to update it. It's Media Technologies, and the article I use is from Tarleton Gillespie about media bias, and it's been helpful, but just looking for other ideas. So I'll email you.
Yeah, please do that. I'm vaguely familiar with that one. That's an oldie but goodie. You know, actually, DJ Hand, as a statistician who's wrote some articles explaining machine learning and data science, and you might look through his stuff like data mining for fun and profit. It's got a little bit of character of I'm talking to statisticians about what data mining and algorithms are. So it gets a little mathy at points, but it's also designed for somebody who knows nothing about machine learning to explain to them what it is and why you would want to do it. To an audience, statisticians, for those of you who don't know, statisticians and data miners, machine learners, it's like you've got this family and you got the two twins who can't stand each other, but they're really similar. And that's kind of what it's like. So a statistician writing an article about data mining to explain why statisticians shouldn't hate it actually might be a good resource. DJ Hand, Data Mining for Fun and Profit. Yeah.
Could you speak a little bit about some of the issues that Gartner puts forth as important? One in particular is the democratization of the tools that we use for data science. And as one who wrote blogs at one point for marketing companies, this whole notion, just like you were saying, do it for the whole world, right?
Yeah.
Well, they're saying that, you can scrape somebody off the street, give them this tool, and they'll be able to, do at least the intermediate stuff leave the hard stuff for the data scientists or whatever. But they use terms like anyone can do it and so forth. The other thing I discovered in that context was the notion years ago of having a salesperson and a sales engineer. There's no sales engineer with them anymore. It's just a marketing person. So that risk that you were talking about in terms of just not being able to vet the capabilities of what you're buying correctly and having the right, any resources, whatever, for being more educated about what to buy.
So I actually believe that there are tools out there today, like Weka, Orange, Kneim, SAS Enterprise Miner, that allow just about anybody to do data mining and algorithms badly.
Yeah.
And my concern is that in a lot of ways, it's not the algorithm stuff, it's not the programming stuff that's the thing that's easy to get wrong. That either works or it doesn't, and it's pretty easy to tell if it didn't work. It's all the issues I'm talking about around validation and algorithmic bias is just one of the many areas of validation. I have a whole week of lectures in my online course about validation of algorithms and models. Those technologies often, say RapidMiner will let you do it all right. It's actually a really good tool for validation. It's really solid, but it'll also allow you to do it all wrong. And so I guess I have concerns about just anybody doing this kind of stuff with no training, because I think that the tools make it so easy to do that you can do horrible, horrible things, and not just algorithmic bias. So when we see tools that make it really easy for anybody to do those things, and they by default make you do it in ways that aren't awful, then I'll feel easier about the idea of just anybody doing it. It's kind of like, look, anybody can get a CAD program and like design a building, right? Doesn't mean that they should be the architect of a condominium in Midtown.
Yep.
Okay, I
Well,
think that's
Thank you.
just about the end of the time, as it turns out. So, Ryan, thank you so much. That was a terrific keynote address. Thanks so much for talking with us.